Now, sometimes we're going to be asked to count things when the fundamental counting principle just cannot apply. So something that we're going to be using a lot of is a standard deck of cards that contains 52 cards. If maybe you're not familiar with a deck of cards and feel a little bit uncomfortable with being able to recall the different suits and stuff like that, just come talk to me, or just invest 5 minutes and do a little research online about that. But you don't hesitate to come and talk to me if you want a few resources on this. So I'm going to be doing these questions assuming that you know what is contained in the standard deck of cards. So don't watch this video until you have a better understanding for yourself as to what a standard deck of cards contains. So count the number of possibilities of drawing a single card and getting, we're counting the number of possibilities. We're not counting the probability yet, that comes next unit, but we're just counting the number of ways that we can draw this out. So that means we're going to use the notation of n, something like a. So the number of elements in a set of a. So So in question A, count the number of possibilities of drawing a single card and getting either a black face card or an ace. So first things first, let's define our sets. So let A equal black face cards, the set of all black face cards. So we're talking about anything in clubs or spades. Let B equal the set of aces. So if we were to draw a Venn diagram with something like this, we would say set A contains Jack of spades. Okay, you're going to love my excellent drawing skills. Queen of spades, because these are just the face cards. And we have the king of spades. But we also have clubs, right? Because we're talking about black cards. So we have clubs and spades. So jack of, now this quickly, okay, it looks good now, but it quickly devolves into looking like a waving hand. Okay, so jack, queen, and king. Good. Okay, so do you get the do you get the point that there are 6 cards here? Oh, good. Now the set of the second set of cards, the B cards, there are aces. So we have the ace of hearts, the ace of diamonds, the ace of spades, and the ace of clubs. Now I want us to make note here, there are no elements that are the same in both. These are what we call mutually exclusive. Because, that's just my shorthand for because, A intersect B is an empty set. There are no things that are common. So if I were to say, find out the number in A union B, I would say the number of elements in A plus the number of elements in B minus the number of elements in A intersect B. So we know the answer. We know that there are 10 because I can count 10 cards here. But let's just go through the formula. So the number of elements in A are 1, 2, 3, 4, 5, 6. Plus the number of elements in B, 4. minus the number of elements in the intersection. Well, there are no intersecting things, so that's just 0. So it's 6 plus 4 is 10. And that's our answer. What about B? So B part is what? Determine or count the number of possibilities of drawing a single card and getting either a red card or a 10. So we're going to do this whole thing again. We're going to define our sets. So B. Let A be the set of all red cards. Let B be drawing a 10 or 10. So if I were to draw this out, now this is not an official Venn diagram, but I just want to show you how these things overlap. So we have our A set, okay, and I'm going to say just hearts, and I'm going to do it shorthanded. I'm not going to go heart 2, heart 3, but just heart 2, 3, 4, 5, 6, 7, 8, 9. I'm going to hold off from writing the 10. You'll see why. We have Jack, Queen, King, Ace, and we have the 10 of hearts. Now, just to be emphatic here, I'm just going to put the 10 of hearts here. For diamonds, so this is the one that we're focusing on, the A, the red cards. So we have 2, 3, 4, 5, 6, 7, 8, 9. I'm going to wait for the 10. Jack, Queen, King, Ace. Just to be emphatic here, I'm going to write the diamond, 10 of diamonds. Now, what about our B? What about our B crew? We have the 10 of spades. We have the 10 of clubs. We also have the 10 of hearts and the 10 of diamonds. So these sets, actually, they overlap. These are not mutually exclusive. Because A intersect B is not an empty set. In fact, there are 2 cards, there are 2 elements. So when we use our principle of inclusion and exclusion, I would say the number of elements in A union B, that's the number of elements in A plus the number of elements in B minus the number of elements in the intersection, A intersect B. So the number of elements in A, we're just going to count them 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, but times 2, because we're not just talking about the hearts, we're also talking about the diamonds. So we have 26 plus the number of elements in B, 1, 2, 3, 4. But we've double counted those, the 10 of hearts and the 10 of diamonds. So let's subtract off what we double counted. So the intersection is 2. Oh, that's silly. The intersection is 2. 26 plus 4 is 30, minus 2 is 28. So the number of possibilities of drawing a single card and getting either a red card or a 10. There are 28 possibilities in our standard deck of cards. Now, so that you can show yourself whether or not you understand, what I want you to do is I want you to go on page 225. Well, sorry, not 225, 235. And I want you to do question 3. This is an important one, okay? Because sometimes you can use the fundamental counting principle and sometimes you can't. So this one right here, you'll see when you get to it. This is an important one. After that, I want you to do questions 5 to 15. I mean, if you can go directly to question 15 and get it, you might not have to do all 5, 6, 7, 8, 9, 10, etc. Okay? However, this gives you a good sense of how much homework I'm expecting you to be able to complete, and these are giving you practice in the types of questions that could potentially be on our test.